Chapter 10, Section 10.7. We are continuing with inequalities. This time we're going to see it in graphing. So graphing, we saw it with graphing on the number line when we had one variable. And now we are going to see it when we graph on a linear inequalities. That's two variables, and it's going to be plotted on an XY coordinate plane. So there are things, transformations give the inequality into an equivalent inequality that is y alone as one side. So we're going to transform it. We're going to set it equal to slope-intercept form. That is typically the format that is most used. Slope, y-intercept, when we isolate for y alone on one side means y is isolated. We can pull out the slope, we can plot the y-intercept, and that's really nice. Graph the equation of the boundary. So the equation, the line, or the inequality will represent the boundary, and that's kind of important. So you either have a solid line or a dashed line. So, and what I've always introduced is when you have greater than or equal to or less than or equal to, we are going to have a line that is solid and points that are closed. We call that closed point, and that means it's equal to. So that it's equal to, it means it's true. So that boundary is going to be a true, will consist of all true points. When we have greater than or less than, our line is dashed, our points are open. That's a new thing. A lot of people don't do that. And we have open, which means that it's false. It's not. So that boundary is false. So this is true, this is false, and we'll call this the boundary. Boundary, we'll call these points, we'll call open or closed points, I guess, yeah. So, and shading, and then so that boundary, whether it be dotted or this is true, this is false, and then there will be a true and false side. So if this is false, this side will be true. If this side is true, this side will be false, or I just did that, sorry. So, or the other way is if side is true, this side will be false. And we're always going to shade the true side. We'll always shade the true side. Okay, so that's a little preface. Here's an example. So the boundary is included because it's equal to. Oh, that's interesting that they wrote the linear equation, and then the inequality there. We will not be doing that. I don't know how many people do that still, but this represents all the solutions to this and that. This just is your boundary line. So we're going to graph this. We're going to set it equal to y. We're going to place it in slope-intercept form, and then I'll show you some new techniques. You can have horizontal or vertical, and we have the true side that's shaded, the false side, true side, false side. That dashed line means that it's, now that's, see, right? That's not y equals 3. That means all the points are true. That's not the case. That is kind of like y is not equal to 3. So I don't know why they would do that. That's kind of silly because that's contradictory. So if I was the math book writer. All right, this is going to be a linear line. First of all, we should notice one variable, and that variable is y. So we're going to cross the y-axis. So this is our x-axis, our y-axis. We're going to cross the y-axis at 2. And it's equal, so we can close the dot. And it will be in a sense, it says it doesn't matter what you plug in for x. Your y will always be greater than or equal to 2. So y is going to be like this. We're going to have a solid line across here. Because if we looked at the other points, we'd notice that the y value is always going to be 2. Y is going to be 2 no matter what my x is, and that's what that graph looks like. Now, this line, this boundary line is true. It's included because it has the equal sign. And now I have to distinguish which side is the true side. One side's going to be true, one side's going to be false. If I pick a point and this ends up being true, then I know all the points on this side is true, and all the points on this side would be false. So I have to test a point not on the boundary. So the easiest point to test is always 0, 0. So I'm going to take my y value from that test point, which is 0. Is 0 greater than or equal to 2? Well, no. That's a false statement. So where that point was, 0, 0 is going to be false. So if this point is false, then all the points on this side of the boundary is false, and all the points on this side are true. So I'm going to shade the true side. You always shade the true side, and it looks like that. Okay, so that's a nice introductory problem. This time, we still have it's going to cross the y-axis at 2, but this time it's going to be dotted because it's not equal to that. So we drew a dot. I do open circle points. And some teachers want you to label some points. We're still going to test 0, 0. And is 0 greater than 2? 0 is not greater than 2. So again, that is false. So this point right here is false. That's where 0, 0 is. So my true side is still, maybe I should do it that way, and we don't get those check marks. So that's the shading, and those are all the true. We're shading the solutions. This time we only have one variable, but it's x, so it's going to cross the x-axis at 2. The x-axis, it is not equal to, so it's going to be, so it's going to be an open circle. So open circle at 2, and this is going to be, all of these points are going to have x values of 2. So I'm still going to test 0, 0, and my x value is 0. Is 0 less than 2? Yes, that's true. So this point is true. So this side is true. So all of these points are true on this side. All the points on the other side are false. Again, single variable. This time it has a equal sign. So I know that 2 is going to be true. And whereas x, that's a bad straight line. So that's what that looks like. And we're going to test 0, 0. Is 0 less than or equal to 2? That's true. So this point is true. So all the points on that side are true. So I'm going to shade to this side where I tested. Wow, lots of single variables. Okay. Open circle. Open circle at 1, dotted line. Dotted line, we're going to test 0, 0, 0 greater than 1. Nope, that's false. That's a false statement. So this point is false. So all the points on that side is false. So that means my other side is shaded, or is true. So we shade the true side. Here's another thing we can do when we see this. We can understand that that could be written as 0x plus 3. You see that? We don't see the x, so the slope equals 0, which is 0 over 1, which is up 0 right 1, and 3 is my y-intercept. So at my y-intercept, I can do a 3 open circle, and then we can go up 0, right 1, up 0, right 1, and that tells me that that is my line. I can test the point 0, 0. I'm going to plug in 0 for y is 0 less than 3. That point is true. So that is a true statement. 0 is less than 3, so I'm going to shade down. Okay, or we can just understand it logically that that would be -1. It's going to be a closed circle on y. We're going to have a solid line. All my points have a y value of -1. Let's test the point. 0, 0 is 0 less than or equal to 1. That would be false. So this point is false. So all the points on that side of the boundary is false. All of this points. Isn't that interesting? And I do a perfect check mark. Wow, are all these going to be? I mean, this is a little over the top. Okay. Closed circle on 3. Show where all my y values are 3. Test the point 0, 0. 0 less than or equal to 3 is true. So this point is true. So I'm going to shade down again. Yay! We have my first slope-intercept form. So y is isolated. The coefficient of x is 1, so that tells me my slope equals 1. My y-intercept equals 3. It's going to be an open circle at my y-intercept. Then I'm going to use my slope, which is up 1, right 1, up 1, right 1. That was an open circle. I'm going to do a dotted line. And then I'm going to test. I'm still going to test my easy point, 0, 0. And this time I'm going to plug in 0 for y. I'm going to plug in 0 for x, because this is my x, this is my y, x, y, and then plus 3. And I'm going to simplify. Is 0 less than 3? That's true. So this point is true. So all the points on that side are going to be true. So I'm going to shade this way. Pretty fun, right? I think it is. So my slope this time is -1. -1. And my y-intercept is going to equal 2. It's an open circle because it's not including. So we get an open circle at 2. We do a slope of down 1, right 1, down 1, right 1. Dotted line along this. We're going to test 0, 0. So if we test 0 for y, 0, oh, -0. That still gives you 0 is greater than 2. That is false. That's a false statement. So this point is false. So that means the other side is going to be the true side. This side is the false side. This side is the true side. And the boundary is false also, hence why we have not colored it in. So this is not necessarily in slope-intercept form. We need our x first and then our constant, which tells me my slope is -1. My y-intercept is going to be 4. I'm going to close circle on 4. My slope is down 1, right 1, down 1, right 1. And we make a solid line along that we're going to test the point 0, 0. Is 0 less than or equal to 4 minus 0? Is 0 less than or equal to 4? That's a true statement. 0 is definitely less than. So this point, 0, 0, is going to be true. And that means all the points on that side are true. So I'm going to shade the true side. Again, not in slope-intercept form. Y mx plus b. So I need my x variable first and then my constant. So negative 2x plus 1. That gives me a slope of negative 2 and a y-intercept of 1. Closed circle, slope of negative 2. That's down to right 1, down to right 1. We can make a line. Now that's kind of close, but I know that 0, 0, so I can still test 0, 0. 0, 0 is not on this line. It's below it. So I didn't draw the best shape, but so we would never want to pick 0, 0 when it's on the line, or else we'll just get whatever the boundary is, true or false. So 0 is greater than or equal to 1 minus 2 times 0, which is 0 greater than or equal to 1. That is false. So this point, 0, 0 is false. Close, but still false. The boundary is true. And if this side is false, then the other side is going to be true, because that testing point did not lie on the boundary. All right, this is in standard form, so we're going to put it in slope-intercept form. We're going to isolate y. We got to get rid of that x. That gives us y is greater than negative x plus 1. That gives me a slope of negative 1, a y-intercept of 1. It's going to be open circle on 1, and then down 1, right 1, down 1, right 1, and dotted line. Let's test the point. We can test 0, 0. It's not through there. 0 plus 0, is that greater than 1? Is 0 greater than 1? That is false. So we know this point right here is false. Blake. So that point's false, so the true side is going to be the other side. And the boundary is going to be false. So we don't shade the boundary. Minus x, negative y is greater than or equal to negative x plus 2. We got to get rid of that negative. So we are going to divide everything by negative 1, everything on the right side, everything on the left side. That leaves us with y. Now we are going to flip the inequality. We have to flip the inequality because we multiply both sides by negative 1. That gives us x minus 2, which means I have a slope of 1, a y-intercept of negative 2. It's equal to, so I'm going to make a dot on negative 2. Then I'm going to go up 1, right 1, up 1, right 1. And I'm going to draw my line using my slope. I'm going to test 0, 0, 0 minus 0 greater than or equal to 2. Is 0 greater than or equal to 2? That is false. Oh, didn't mean to do it in red. We want that in black because we're saving the red for the point. So that point is false. So we're going to shade the other side. Good. Testing. 1, 2. Okay. So let's isolate for y. We get negative 2y is less than or equal to negative x minus 4. Divide by negative 2. We get y is greater than or equal to 1/2 x positive, because negative divided by a negative is a positive, plus 2. Again, a negative divided by a negative is 2. So we have a slope of 1/2 and a y-intercept of 2. Close circle on 2, slope 1/2, up 1, right 2, up 1, right 2. We're going to test the point. 0, 0 is 0 minus 2 times 0 less than or equal to negative 4 is 0 minus 0 less than or equal to negative 4 is 0 less than or equal to negative 4. That is false. So, since it's false, this point is false. Oh, I did it in red again. Getting tired. 7:46 on a Saturday. That point's false, so let's do the other side, because that's going to be the true side. And the boundary is also true, so hence why it's shaded. Minus 2x minus 2x, y is greater than negative 2x minus 2. That has a slope of negative 2, a y-intercept of negative 2. Open circle because it's not equal to, so open circle at negative 2. We're going to go down to right 1, down to right 1, and we're going to make a dotted line to show that we do not include the boundary. We're going to test the point 0, 0. Is 2 times 0 plus 0 greater than negative 2 is 0 plus 0 greater than negative 2 is 0 greater than negative 2. That is true. That is a true statement. Finally, that point is true. So that point is true. That whole entire side is going to be true. And we always shade the true side. Minus 3x, negative y is greater than negative 3x plus 6, divide by negative 1, divide by negative 1, divide by negative 1. Y is greater than positive, we divided everything by negative, sorry, is less than 3x minus 6. Slope of 3, y-intercept of negative 6. Open circle, 1, 2, 3, 4, 5, 6, negative 6 on the y-axis. We're going to go up 3, 1, 2, 1, 2, 3, right 1, 1, 2, 3, right 1. So that's pretty steep. That's dotted because it is not equal to. We're going to test the point 0, 0. By the way, you can test any point other than a point on the boundary. I just choose 0, 0 because, oh my goodness, I just pinched my frozen shoulder. Oh, that hurt a lot. All right, we're going to test the point 0, 0. 3 times 0 minus 0 is greater than 6. 0 minus 0 is greater than 6. 0 greater than 6. 0 is not greater than 6, people. That is a false statement. So that point is a false point. That is not a solution. So the other side will contain all the solutions. That's the neat thing, is if one point is false, then all the points on that side of the boundary is false. I did it again. There's something with my right arm when I'm writing, I'm a lefty, that tweaks it. Sorry. Whew, that hurt a lot. Plus 2x plus 2x. Y is less than or equal to 2x minus 6. That has a slope of 2, a y-intercept of -6 again. This time it's closed on -6. 1, 2, 3, 4, 5, 6. Slope of 2, up 2, right 1, up 2, right 1. Testing. So 0 minus 2 times 0 is less than or equal to -6. 0 minus 0 less than or equal to -6. Is 0 less than -6? No, it is not. That point is false. Did I write false? Yeah, maybe. Did I write false? I did not. False. Did I write true? Yep. Did I write false? Oh, just F. Just checking on them. Sorry. That's false, so that tells us that the other side is true. All right, a couple more here. Solving for y minus 2x minus 2x. This is a good practice for isolating variables when you have multiple variables in that equation. Divide by -3, divide by -3, divide by -3. Y is less than or equal to 2/3 x minus 2. That has a slope of 2/3 and a y-intercept of -2. Remember, slope is rise over run. So we're going to rise +2. We're going to run +3. But first, we're going to plot our y-intercept at -2. Rise 2, +2 is up 2, +3 is right 3. Up 2, right 3. Let's test the point. 0, 0. We have 2 times 0 minus 3 times 0 is greater than or equal to 6. That's going to be a false statement. 0 is not greater than or equal to 6. Yes, I know I did it in red. I've been doing I just hit that red button, red pen. That's false. So let's graph the other side of the equation, or the boundary, sorry. Ooh, let's add 3x. Ooh, I like this one. Do I like this one? No. Yeah, yes, I like this one. 2y is less than 3x. Divide by 2, divide by 2. Yep, I like this. 3 halves x. So my slope is the easy part. 3 halves. My y-intercept is going to be 0. I'm going to have an open circle, up 3, 1, 2, 3, right 2. 1, 2, 3, right 2. Dotted line. And you already see why I like this. So now, what point are we going to test? We can't test 0, 0 because the line goes through 0, 0. Do you know what we're going to get if we plugged in 0, 0? Yeah, we'd get false because the point is on the boundary and the boundary is false. So any point on that boundary would report a false value. So we got to test something else. I don't know if I'm going to do 1, 1 because that's kind of close. I'd do it in the other quadrant. This boundary goes through quadrant 1 and 3. So I'd probably pick a point on quadrant 2 or quadrant 4. So I'm going to pick -1x, +1y. And we'll plug it in. So my y is +1, my x is -1, and I'm checking to see if it's less than 0. So I get 2 plus 3 less than 0 is 5 less than 0. That's false. So I know this point, 1, 1, -1, 1 is false. So I know all the points on the other side are going to be the true side. That's going to be the true side of the graph, or the solutions. This is where all the solutions lie. Whoa, look at that. Holy moly. All right, let's simplify. I gotta get rid of Chewbacca here. And in order to get rid of Chewbacca, I either need to divide by 2, but who wants to deal with those by dividing by 2, or we can distribute. So you get 3y minus 5 is greater than 2x plus 4y. Let's move the y's to the same side. Ooh, I don't want to move it that way. Why don't I want to? Because I don't want a negative y. I'm going to move the y's over to the right, and I'm going to move the x's to the left. So these cancel, these cancel. I'm left with negative 2x minus 5 is greater than y. So my slope equals negative 2. My y-intercept equals negative 5. It was less than technically. So I'm going to have, or it's not equal to, so I'm going to have an open circle on negative 5. 1, 2, 3, 4, 5. Open circle. I'm going to go down 2, right 1, down 2, right 1. I'm going to do a dotted line. I'm going to test the point. 0, 0. And 3 times 0 minus 5 greater than 2 times 0 plus 2 times 0. So let's simplify that. 3 times 0 is 0, minus 5 is greater than 2 times 0 plus 0. 0 minus 5 is negative 5, greater than 2. 0 plus 0 is 0. Is negative 5 greater than 0? That is false. This point is false. So I'm going to graph the other side, or shade the other side. 3 more. So, okay, let's move that constant over. You get 2y is greater than 3x minus 4. Let's divide everything by 2. You get y equals 3 halves x minus 2. That has a slope of 3 halves, a y-intercept of 2. That's not equal to, so it's going to be open at 2, and then the slope up 1, 2, 3, right 2, up 1, 2, 3, right 2, dotted line. It kind of looks like a closed circle. I will open it up a little bit. Let's test the point 0, 0. 2 times 0 minus 1 greater than 3 times 0 minus 5. We're going to simplify. 0 minus 1 greater than 0 minus 5 is negative 1 greater than negative 5. That is true. Negative 1 is greater than negative 5. So this point is true. So we know that all the points on that side will be the true side. Thought I only had 2 left. Apparently not. We're not going to divide by 3 to get rid of Chewbacca. We're going to distribute. 3x minus 3y is greater than or equal to 2x plus 1. We're going to move the x over, Negative 3y is greater than or equal to negative x plus 1. Divide by negative 3, divide by negative 3, divide by negative 3. Y is less than or equal to, we divided everything by a negative, both sides. We get 1/3 x minus 1/3. How fun is this going to be? My slope equals 1/3. My y-intercept equals negative 1/3. So my y-intercept is negative 1/3. That's a closed circle at least. I don't have to do an open circle. Then we're going to go up 1. So that's going to be 2/3. Oops, sorry. We're going to go up 1 and then right 3. So that's going to be right there, just at 2/3. We're going to go up 1 and right 3. That's going to be at 1 2/3. We're going to have a solid line. We're going to test the point, 0, 0. It's going to be close to that line. So what is my original equation? 3 times 0 minus 0 is greater than or equal to 2 times 0. I think that was plus 1. So 3 times 0 greater than or equal to 0 plus 1 is 0 greater than or equal to 1. That is a false statement. So this point is false. It's not on the border, so you're fine. That side is all going to be false. So these are going to be true. I'm going to shade that side. Last one. We can divide everything by 2 because they're multiples of 2. So that gives us 2y minus 3 is less than x plus y. Yeah. Let's minus the y to the other side. Let's add the 3 to the other side. These cancel, these cancel. You're left with y is less than x plus 3. That has a slope of 1, a y-intercept of 3, not equal to, so open circle, slope up 1, right 1, up 1, right 1. We're going to test the point, test 0, 0, so we get 4 times 0 minus 6 less than 2 times 0 plus 0. That's 0 minus 6 less than 2 times 0. That's negative 6, and that's 0. And that's still true. Negative 6 is less than 0. That point is true. That means this point is true. That means this side is true. And that, ladies and gentlemen, is graphing linear inequalities. Graphing linear inequalities. Good, very important. It can get really fun when you start systems of linear inequality, probably going to be section 10.8, which we'll be doing momentarily. Good luck.